Hi, chemistry students. So we've learned a lot of different kinds of calculations. You know how to calculate the molar mass, and you remember that the molar mass of a substance is equal to 1 mole of the substance. You've learned how to convert from moles to grams and grams to moles. You have learned how to use a chemical equation to study the relationships between reactants and products and between reactants and products. So we are going to use all of those skills that you have learned over the last couple of weeks in order to determine from a balanced equation which reactant is the limiting reactant, which one is the excess reactant, and what is the theoretical yield of a certain product. So in order to do this, I'm going to use the worksheet that you see in front of you. I gave you a handout of this in class. We did the cookie part together, and now we are scrolling down so that we can take a look at a couple of the problems. So what we have here is question number 1. We have 5.37 moles of solid sodium reacts with 20.9 grams of aqueous aluminum nitrate according to the following equation. And you can see we have an equation here. So we need to determine the theoretical yield of aluminum. And I know it says in grams here, but I'm going to go ahead and cross this out. I would just like you to be able to find out how many moles of aluminum we get. And in order to figure out part A, we actually have to do part B first. We have to figure out what the limiting reactant and the excess reactant are first. Okay, so let's get started. As in any of the problems that we have done over the past couple of weeks, we first need to balance our equation. And I'm not going to go through all the steps with you because this is going to be a long enough video. So once you look through it all, your balanced equation will have 3 moles of sodium plus 1 mole of aluminum nitrate yields 1 mole of aluminum and 3 moles of sodium nitrate. So let's take a look back at our problem. Like, we want to figure out how much aluminum in moles we're going to get. But we're also given some other parameters, right? We're told that we have 5.37 moles of solid sodium, which is Na. And the first thing we need to do is take a look at our equation. We're given 5.37 moles, but our equation only calls for 3 moles. So we have a lot more of sodium than what we need. So in this case, it's pretty simple. We are going to call sodium our excess reactant. And so there, I did the very first part of part B where it says label the excess reactant. Okay, we did that. Well, now let's take a look at our aluminum nitrate. Now, according to the equation, we are going to need only 1 mole of aluminum nitrate. Well, we need to know how many grams 1 mole of aluminum nitrate is because our problem tells us that we have 20.9 grams of aluminum nitrate. We need 1 mole of that. So let's see how much 1 mole of aluminum nitrate weighs. Well, we already know that 1 mole of any compound is equal to the molar mass of that compound. So let's start by calculating the molar mass of aluminum nitrate. So in order to do that, I need to consult my chem helper. All right, so after consulting my chem helper, I can see that 1 aluminum, 3 nitrogens, and 9 oxygens gives me a molar mass of 213.01 grams, and that's equal to 1 mole of aluminum nitrate. But oh my gosh, look at, we only have 20.9 grams. That's way less than what we need in order to run this reaction. So we can label aluminum nitrate as our limiting reactant. This is the reactant that's going to hinder the amount of product that can be made by our reactant. Okay, so we've labeled our excess reactant, we've labeled our limiting reactant. Now we can use our limiting reactant in order to determine how much product we're going to get. And if you look at what I underlined in purple here in letter A, we are trying to figure out how much aluminum we can get if we run this reaction with only 213.01 grams of aluminum nitrate. All right, so as a reminder, you should use your limiting reactant as the given to determine the theoretical yield of products. So let me show you what that means. So the limiting reactant, we already decided, is aluminum nitrate, and my problem says that we have 20.9 grams of aluminum nitrate. So I'm going to write that first. So I have 20.9 grams of AlNO3. That's my given. And just like with our other stoichiometry problems, if we are moving from grams of one substance to moles of another substance, my very first proportion is going to be the equation that 1 mole is equal to the molar mass of my compound. So I'm going to write 1 mole of aluminum nitrate on top, and I'm going to write the molar mass of aluminum nitrate, which we already figured out, on the bottom. Okay, what this means is that as I move through this problem, I'm able to cancel out grams of aluminum nitrate. I don't need it anymore. I have moles left here on top. And, whoops, and now I'm going to write my final proportion, and this is the mole ratio that I get from my equation. I'm going to write moles of aluminum nitrate on the bottom here so that I can cancel it out when I do the math. And I'm going to write moles of what I'm looking for. So that's moles of aluminum on top. The numbers that I put here come from my balanced equation. So I have no number in front of aluminum nitrate. That means that our equation says we have 1 mole of it. We need 1 mole of that. And I also have no number in front of aluminum. So that means I also have 1 mole of aluminum according to my equation. So now I'm ready to do some calculations. But first, the fun part, I get to cancel moles of aluminum nitrate, and what I am left with is what I'm looking for in the problem, moles of aluminum. So to figure this out, I am going to circle the numbers that I'm going to multiply across the top. So I'm going to multiply 20.9 times 1 times 1, and guess what? That is simply 20.9. And I'm going to multiply across the bottom. I'm going to circle these numbers in green. 213 times 1, and that's what I have on the bottom. Now, in your calculator, you should punch in 20.9 divided by 213.01. And once I do that operation, I get 0.01. I rounded that. 0.01, And then I'm going to copy down my units that are left. Moles of aluminum. And that is my answer to letter A. And this should make sense because, like I said at the very beginning, a mole of aluminum nitrate, one of our reactants, weighed 213.01 grams, but we only had 20.9 grams. So we had a lot less than what we needed for the reaction. So our final product, what we were looking for, our aluminum, would be way less than what we should normally get. Normally we should only get 1 mole, but using that small amount of aluminum nitrate gives us way less than 1 mole, and that's exactly what we have. So our problem makes sense. All right, now let's take a look at our next equation here, and I'm going to do the same thing though before we do anything else. I'm going to take grams in part A, cross it out, and let's make it moles here. Okay, great. So what we have here is a problem. It says that we have 250.4 grams of aqueous calcium chloride, and that reacts with 540.8 grams of aqueous lithium phosphate according to this equation. So we need to figure out how much lithium chloride we have. So we're looking for how much of this product we get. And we need to, just like above, label the theoretical yield, label the limiting reactant, and also the excess reactant. So before we start with this, what I want to do is just write down the formulas for you up here. So this is CaCl2 for calcium chloride, and lithium phosphate is Li3PO4, just so that we don't get confused there. And as we take a look at the equation, we are not balanced, not yet. If we add the coefficients of 3 and 2 and 6, however, we are now balanced. Okay, so our balanced equation is here, and before we can start figuring out the theoretical yield, we first have to determine which of our reactants, calcium chloride or lithium phosphate, which of those are limiting and which of them is the excess reactant. So let's explore that a little bit. So our equation says that we need 3 moles of calcium chloride. Our problem says that we have 250.4 grams of calcium chloride, but I don't know if this 250.4 is enough or not. I need to find out how much 3 moles of calcium chloride weighs in grams. So in order to do that, so I'm going to first find out how much each reactant weighs in grams. Okay, so let's start doing that. So in order to figure that out, I'm going to take my given. My given is 3 moles of calcium chloride. So 3 moles of CaCl2. And I'm going to multiply that by the equation that we already know, that 1 mole of CaCl2 is equal to the molar mass of this compound. So in order to find the molar mass of CaCl2, I need to refer to my chem helper. And so I wrote the molar mass calculation off to the side in purple. So I have 1 calcium at 40.08 grams. Again, I got that from the periodic table. And I have 2 chlorines. Each of them weigh 35.45 grams. And then when I add that together, I get 110.98 grams. And that's equal to 1 mole of calcium chloride. So now, if I cross out my units, I see that I have to multiply 3 times 110.98, and that equals 332.94 grams. Well, if we look back at the problem, I see that we only have 250.4 grams, and we need 332.94 grams of calcium chloride. Therefore, calcium chloride is my limiting reactant here. It's going to hinder the amount of product, the amount of lithium chloride that I starred, that I can produce. So great, we found our limiting reactant. Let's just make sure then that lithium phosphate isn't limiting also. So let's figure that out. So number 2, our second step is we need to find out how much 2 moles of lithium phosphate weighs. So I'm going to follow the same pattern here. 2 moles of lithium phosphate. And I'm going to multiply that by my equation that I already know, that 1 mole of any substance is equal to the molar mass of that substance. And to find the molar mass of lithium phosphate, I have to consult my chem helper. All right, so I wrote out the molar mass calculation for lithium phosphate in orange off to the side, and it looks like 1 mole is equal to 115.79 grams of lithium phosphate. Okay, great. So now in order to solve this, I am going to cross out, that's the fun part, moles of lithium phosphate, and now I just need to multiply 2 times 115.79, and when I do, I get 231.58 grams of lithium phosphate. And if I look back at my problem, I see that I have a lot of lithium phosphate. I have much more than I need. I have 540.8 grams of lithium phosphate. So lithium phosphate is my excess reactant. Okay, so now what we have to do is find out, using my limiting reactant, I need to find out how much lithium chloride I can actually produce. All right, so just remember that when you're trying to find out how much you can actually produce, you need to use your limiting reactant. Okay, so if we look back at our problem, we see that we have only 250.4 grams of calcium chloride, and that is our limiting reactant. So let's use a different color here. Let's use blue. So, oh shoot, now I forgot the number. 250.4. So we have 250.4 grams of calcium chloride. And remember that since I'm starting with grams, that means that my first proportion is 1 mole is equal to the molar mass of the compound. So 1 mole of calcium chloride is equal to the molar mass of calcium chloride, which I already calculated as 110.98 grams. Now, how did I know to put grams on the bottom? Because that's what I'm given. And by putting it on the bottom, as I roll through this calculation, I'm able to cancel out my units that I don't want. Okay, great. So now what I'm going to do is multiply by my mole ratio. So remember that when you start with grams, the mole ratio is the last proportion that you make. So since I have moles of calcium chloride on top, I want moles of calcium chloride on the bottom, and I'm going to put moles of the compound that I'm looking for, which is lithium chloride, on the top. What numbers go here? Well, I have to look at the coefficients in my equation. The coefficient for calcium chloride is 3, and the coefficient for lithium chloride is 6. So, in order to figure this out, I want to multiply 250, let me get a different color here, 250.4 times 1 times 6, and when I multiply that out, I get 1,500. And along the bottom in purple, I need to multiply 110.98 times 3. And when I do that, I get 332.94. So in my calculator, when I perform this operation, I need to punch in 1,500 divided by 332.94. And when I do, I get the number 4.5 moles of lithium chloride. And that is my answer. So, chemistry students, this is how you can use your limiting reactant to determine how much product you can get. This is the same thing that we do when we look at a cookie recipe. If the recipe calls for a whole cup of sugar, but I only have a half a cup, that's going to affect how much product I can make. And that is the big takeaway from this exercise. Thanks for watching.